my case, it's a love for design, creation, and specifically hands-on building. But I want to start today by talking about why you should care about my field, mechanical engineering. In short, mechanical engineering is the application of science and engineering to everything around you. You can pick any item in this room, and mechanical engineer was involved in every step of the process. In fact, Melina, I'd like you to pick an object. So this podium here is made of probably rolled steel. An engineer had to figure out the specific composition of the metal, the design of the machine that would press it, the design of the machine that would fold it into this shape, and then beyond that, the packaging of the box that it was put in, the way that it was transported to the store, the way that it was marketed in the store, how it was held on the shelves, the way that it was transported to the end user. Mechanical engineers are involved in every single step of the process and are extremely integral to our economy. So for a textbook definition, mechanical engineering is the discipline that applies the principles of engineering, physics, and material science for the design, analysis, manufacturing, and maintenance of mechanical systems. It is the branch of engineering that involves the design, production, and operation of machinery. So basically that just says anything mechanical is mechanical engineering, believe it or not. In short, though, it is the application of science to any and everything around you. So my quote this year, I think, really goes with mechanical engineering. It's a quote from Leonardo da Vinci, and he said, "It had long since come to my attention that people of accomplishment rarely sat back and let things happen to them. They went out and happened to things." Now, why the grammar of that is maybe a little questionable, I think that it really characterizes the spirit of mechanical engineering. If you want to see a change, you go out and make that happen. You design it, you create it, you build it, using your knowledge of science and material science, those sorts of things. So my mission statement this year, it's a little long, but it says, "I will find a mentor that is doing exciting things, and I will learn what they are doing, how they are doing it, and why they are able to do so that one day, I too can do exciting things. I will gain the knowledge and make the connections that will set me up for success and set me apart from my peers. In all things that I do, I will choose character and choose excellence and exemplify character." Don't mess that one up. So this is my second year in ISM, so I think it's kind of important to talk about my experience last year. I focused on a big project that was my electric car, and along with that, I kind of researched, the future of transportation and alternative energy sources, renewable energy, stuff like that. So I kind of wanted to continue that theme this year. Some of the things that I've researched, the very first thing I researched was a basic rundown of the biggest challenges facing engineers in the future. Now, there were 14 different topics that I studied, but I wanted to highlight just a few of them. So the first one is making solar affordable. We all know that solar power is kind of an up-and-coming technology, but you don't see it a lot around here. It doesn't really make sense because this is a very bright, sunny area, and electricity isn't particularly cheap here. So the reason for that is that solar panels right now are not very efficient, and they're not very cheap. It costs a lot of money, usually about $15,000 to as much as $50,000 to put solar panels on your roof. Now that's a lot of upfront investment for something that's going to pay off in very small increments over many, many years. So a big challenge in adopting this technology is making it affordable. If we can make it affordable, it'll be adopted by the community much more widely, and we'll have much more renewable sources of energy powering our homes. The next thing is to generate power from fusion. Now you might say, if you can generate power from fusion, why do you need solar? And the answer is that generating power from fusion is probably something that's 100 years off. So we need something in the meantime. Fusion is a kind of nuclear power. The main kinds of renewable energy are solar, wind, and nuclear. The nuclear that we use today is fission. Basically, we split atoms and capture the energy released by that split. Fusion is the process of merging atoms. And it produces much, much more power, but it's very, very hard to control. It creates an explosion similar to that of the Big Bang. So imagine containing all of that in a system and capturing that power. If we can do that, we can power the entirety of the United States for a day with a piece of material about that big. So it offers great potential, and it could really change the way that we generate power, but it's kind of a long way off. The next thing is develop carbon sequestration. Now, sequestration is basically a big word for capture. So this is carbon capture. Again, we all know that we've done a pretty awful job at maintaining our environment. We've polluted it, we've put carbon in the air. So what can we do to take it back out? Right now, there's no technology available for this use. The carbon is there, and we're only adding to it. There's no way to decrease it. We can slow down how quickly we add to it, but we can't take it back. If we can develop carbon sequestration, basically a way to take carbon out of the environment, we could much more effectively manage our environmental impact. This would basically look like giant air scrubbers that capture carbon dioxide and pull it out of the environment. Next thing is to provide access to clean water around the world. If you think about it, we in America don't really consider clean water. It just comes out of the faucet. All around the world, though, it's a significant problem. As you can see, that's the kind of water that people are drinking. Now, it's not a problem of the availability of water, it's the technology needed to purify it and make it safe for drinking. Now, right now, similar to solar, there are solutions available, but they're not very efficient and they're very expensive. If we can engineer better solutions to clean water, or even tap into underground reserves, things like that, we can provide access to clean water for people around the world. The last thing that I wanted to highlight from that study was to modernize urban infrastructure. Here in America, and really around the world, we have an urban infrastructure that was developed about 60 to 70 years ago, and it's really starting to crumble. The big challenge for engineers in the future will be developing an infrastructure that serves the needs of the future. Now, this will look very different from how we designed it in the 1950s, and that'll be a big challenge. Another thing that I studied this year was the application of this year's Nobel Prizes to the field of mechanical engineering. Basically, you would think that the fields most applicable to engineering are physics, chemistry, and maybe economics. Now, the report that I read suggested a fourth, and that was actually the field of literature. Now, basically it said that in physics, chemistry, and economics, there were some things that may be applicable to engineering in the distant future, but right now they're too theoretical. But in literature, it suggested that Bob Dylan's prize for his songwriting could have had an impact on the way that engineers think about the world and solve problems. It was kind of out there, but it was an interesting perspective on how the environments around us shape the way that we solve problems. I also read about the advancements made in the automation of transportation. So Tesla has recently unveiled their Autopilot Part 2, which Autopilot Part 1 is what we know today. Basically, you get on the highway and it maintains your lane. It'll change lanes for you. It'll make sure you don't wreck. But it can't take you through side streets or from your house to where you're going. Automated Part 2 will take you door to door. In fact, you can hit a button, your car will come to you wherever you are. You get in, you sit back, and it takes you to your destination. So that's kind of the future of where we're going with that. I also read about solar roofs. So as we've talked about, solar is a major area of potential in the future of energy and transportation. So, like I said, the problem has been that it's been very expensive, and it's also been very unsightly. If someone has solar panels, you know it. You see the big blue squares on their roof. Tesla and their partner SolarCity have come out with a solar roof that blends in with all the others. This is actually a roof entirely covered in solar panels, and you'd never know it. They're disguised to look just like regular ones. Now, of course, they're not very cheap, but they are supposed to be about the cost of a brand new roof. So this is really an area of potential and could be a pivot in this industry. So going forward this year, one of my major goals is to donate my car. I want to find a program that will use it and use it as a teaching tool for students interested in STEM. I've actually started talking to the Boy Scouts, and I think that that could be a great partner. So that's kind of my main goal. And I guess I'm asking that you all help hold me accountable to my goals, making sure that that happens by the end of the year. Thank you for your